Welcome to another Under the Night Sky. My name is Robin. Tonight we're going to explore the constellation of Auriga the Charioteer. I'll talk about how to find Auriga, a couple of its interesting stars, some deep sky objects located in the constellation, and some of the myths associated with Auriga. By late November, the sun is setting at about 5 o'clock. By 7:30, the constellation will be high enough and the sky dark enough to see Auriga. What we look for is a pentagon shape. Auriga is Latin for charioteer. He's a charioteer driving his chariot while holding a she-goat over his left shoulder and her 3 kids under his left arm. Don't worry if you find that hard to see in these stars. Most folks do. Auriga is a large constellation and one of 6 that dominate the winter sky. The other 5 are Taurus, Orion, Canis Major, Canis Minor, and Gemini. Because of where we are located in northeast Ohio at a latitude of about 40 degrees north, all the constellations within this blue circle never set for us. We can see them every night of the year. They're called circumpolar constellations. Auriga lies just outside the circumpolar circle, but is close enough to be considered a circumpolar constellation because we can see at least part of it on every night of the year. Here we see Auriga at 6:30. Let's watch how it moves through the night. Here is Auriga at 9:30. At 1:30 in the morning, Auriga is at its highest point in the sky. This is Auriga at 4:30 in the morning and at 6:30 in the morning. After 6:30, we start to lose Auriga in the morning twilight, which is just starting to show in the east on this image. If you want to see all of Auriga, start looking in October. As the nights go by, the constellation moves higher in the sky and is well positioned for viewing throughout the winter months. There are 2 constellations that I've discussed in previous Under the Night Sky videos that may help you find this constellation. The first is the constellation of Perseus. Auriga follows Perseus through the sky. The other constellation is Taurus the Bull. Taurus shares a star with Auriga. You can also look for this small triangle of stars. This triangle is an asterism called the Kids and represents the 3 baby goats tucked under Auriga's left arm. Let's look at some of the interesting stars that form this constellation. First, we'll look at Capella. And even though it doesn't look like it in this image, it's a golden yellow star marking the charioteer's left shoulder. You may have heard this star called the goat star. In fact, Capella is Latin for she-goat. When low on the horizon, Capella seems to twinkle and dance with changing colors of blue, red, and green. This phenomenon is caused by the Earth's atmosphere. When near the horizon, we are viewing Capella through a thick layer of constantly moving atmosphere. As it rises, we see it through thinner layers of atmosphere, and as it gets higher in the sky, it looks like a shining diamond. It's the brightest star in Auriga, the 6th brightest star in the night sky, and the 3rd brightest star in the northern celestial hemisphere. Part of the reason it's so bright is that it's close, being only 43 light years away. A light year is the distance light travels in a year, about 6 trillion miles. So the distance to Capella is 43 times 6 trillion miles. To the naked eye, Capella appears to be a single star. It's actually a group of 4 stars. 2 giant binary stars, Capella AA and AB, and 2 much fainter binary dwarf stars, H and L. Capella's 2 yellow giant stars are extremely close, separated by about 71 million miles. That's about the same as the distance from the Sun to the planet Venus. They revolve around their common center of mass every 104 days, which is about the same amount of time it takes Mercury to revolve around the Sun. From our viewing perspective on Earth, These two stars never eclipse each other. These two images were taken 2 weeks apart and clearly show the orbital motion around their common center of mass. The two are so close they can't be split using a telescope. Capella AA and AB can only be seen as two stars by using interferometry. These images were taken by COAST, short for Cambridge Optical Aperture Synthesis Telescope. In contrast to the two giant stars, the two red dwarf stars are separated by 48 astronomical units, or about 4.5 billion miles, and orbit each other once every 388 years. These dwarf stars orbit the yellow giants at a distance of 10,000 astronomical units, or about 932 billion miles. This last graphic is a size comparison of the stars in the Capella star group and our Sun, or Sol. As you can see, our Sun is much bigger than the red dwarfs and much smaller than the yellow giants. Now let's look at the star Epsilon Auriga, also called Almaz, which is Arabic for he-goat. It's the top star in the triangle asterism called the Kids that I showed you earlier. This is an artist rendering of Epsilon Auriga. Located about 1,350 light years away, the system is an eclipsing binary variable, meaning Epsilon Auriga dims when its companion blocks its light. Every 27 years, the light from Epsilon Auriga dims for a period of 640 to 730 days, about 2 years, and then brightens. The star's light is being blocked by something dark and of truly colossal proportions. For over a century, astronomers were puzzled by this mysterious dark companion. Using the Chara array, an optical interferometer located on Mount Wilson, California, astronomers imaged the 2009 to 2011 Epsilon Auriga eclipse. The images show a wedge-shaped object moving across the face of the star. This is an animation of the Chara data showing the 2009 to 2011 eclipse. Prior to this, astronomers hadn't observed much light from the dark companion. Their thinking was that it was a smaller star orbited by an edge-on, thick disk of dust. For this to be true, the orbiting disk had to be in precisely the same plane as the dark object's orbit around Epsilon Auriga, and this had to be in the same plane as our view from Earth. The Chara images prove that this is exactly what is happening. A geometrically thin, dark, dense, but partially translucent cloud can be seen passing in front of Epsilon Auriga. This is an artist concept of Epsilon Auriga and its dark companion. The disk and its star are probably similar to our solar system some 4.5 billion years ago, when planets were beginning to form. The dark companion is a mystery no more. Let's move on to some deep sky objects. Here's the location of IC 405, an incredibly beautiful nebula, and the star AE Auriga. The nebula is called the Flaming Star Nebula. Lying about 1,500 light years away, the nebula is lit by AE Auriga, a runaway star at the upper left of this image. AE Auriga is a massive hot blue star moving at 230,000 miles per hour relative to our Sun. Tracing its path back 2.5 million years, we know that it was ejected from a collision of multiple star systems near the Orion Nebula. Purely by chance, the star is currently passing through the Flaming Star Nebula, a cold cloud of interstellar gas and dust. The nebula is both an emission nebula and a reflection nebula. The star's ionizing ultraviolet radiation causes the nebula to glow red as hydrogen atoms are stripped of their electrons and recombined. The blue wisps are created by the blue light of the star being reflected by dust in the nebula. It's the rippling dust and gas lanes that give the Flaming Star Nebula its name. This is a photo of the Flaming Star Nebula taken by Phil Creed, one of our Astronomy Club members. Next, we have 3 open star clusters, M37, 36, and 38, which from Earth appear to lie in a line. An open cluster is a young grouping of stars loosely bound by gravity that formed from the same cloud of gas and dust. Open clusters can contain a few stars to thousands of stars. There are 19 open clusters in Auriga. These 3 clusters are visually the brightest. In dark, clear skies, all 3 can be seen with the naked eye. Lying 4,000 to 4,500 light years away, M36 is the youngest of the 3 clusters, with an estimated age of 16 to 125 million years old. It's also the smallest of the 3, containing at least 60 stars. Being young, it contains both bright and faint stars, but no red giants. There are several arcs and chains of stars throughout the cluster, and a dozen or so of the brightest stars make up the densest part of the cluster. Containing thousands of stars, M37 lies about 5,000 light years away and is the brightest and richest open cluster in Auriga. It's been described as the prettiest and most striking of these 3 clusters. M37 is quite a bit older than M36, having an estimated age of 650 million years. So not only does this cluster contain hot blue stars, it also has a sprinkling of red giants and a few white dwarfs. You can see the brightest red giant star near the center of the cluster. M38 is about as large as M37, but it's not as rich or bright. Its age lies between the other 2 at about 300 million years. Using binoculars, you see a couple dozen stars. In a telescope, there are more stars scattered over a large area, and they appear to be arranged in several irregular chains of differing lengths. This cluster is about 3,400 light years distant. One last deep sky object, IC 2149, a planetary nebula. This infrared image was taken by astronomers from the University of Arizona using their 6.5 meter multiple mirror telescope on Mount Hopkins. IC 2149 is about 6,600 light years away and about 50 light years across. The remaining central star is the brightest object in the image. On either side of the central star, what we see is a dense, irregular ring seen almost edge-on. Based on what astronomers have learned about the nebula, it's believed that the origin star was low mass like our Sun. IC 2149 could be showing us our Sun's future. Let's move on to some mythology. In Sardinian folklore, Auriga is called the fence for sheep. To the Inuit, the bright stars Capella and Menkullinon in Auriga and the bright stars Castor and Pollux in the constellation of Gemini form the constellation called the Collarbones. The name comes from the resemblance to a set of collarbones. Although the constellation seems to be known all over the Arctic, there are no known legends associated with it. Capella is one of the stars in the Dakota-Lakota people's racetrack constellation. The constellation is tied to the story of the great race between the four-legged and the winged ones to determine the fate of the two-legged being people. The sacred racetrack can be seen in the red clay surrounding the Black Hills. The red color is the blood trail of the animals in the race. The Burong people of Australia see Capella as a red kangaroo being hunted by two hunters represented by the stars Castor and Pollux in the constellation Gemini. In Australia, Capella rises barely over the horizon, making the red kangaroo difficult to see. It's said that it's like trying to see a plains kangaroo far out in the distance in the summer heat through a mirage. There are several Greek myths about the charioteer. One of the stories is that Hera, goddess of heaven, had a child who was born lame. Only those who were perfect could live among the gods, so the child was sent to Earth. He became the blacksmith known as Ephesus. He made beautiful ornaments and armor for the gods. It's said that he invented the chariot so that he could get around better. Also in Greek mythology, Capella has been called Amalthea, the goat that suckled the infant Zeus when he was on the island of Crete. In gratitude, she was placed in the sky along with her kids. That's it for this Under the Night Sky. Thank you for watching, and I hope you've enjoyed exploring Auriga the Charioteer with me. Join me in February when we explore the constellation of Gemini the Twins.